This is day 23 of Advent of Code 2023, and this challenge is called A Long Walk. The elves resume watering filtering operations. Clean water starts flowing over the edge of Island Island. They offer to help you go over the edge of Island Island too. Just hold on tight to one end of this impossibly long rope and they'll lower you down a safe distance from the massive waterfall you just created. As you finally reach Snow Island, you see that the water isn't really reaching the ground. It's being absorbed by the air itself. Looks like you'll finally have a little downtime while the moisture builds up to snow producing levels. Snow Island is pretty scenic, even without any snow. Why not take a walk? There's a map of nearby hiking trails, the puzzle input, that indicates paths, dot, forest, hash, and steep slopes, caret, greater than, v, less than. So for example, this. So you're currently on the single path tile in the top row. Your goal is to reach the single path tile in the bottom row. Because of all the mist from the waterfall, the slopes are probably quite icy. If you step onto a slope tile, your next step must be downhill, the direction the arrow is pointing. To make sure you have the most scenic hike possible, never step onto the same tile twice. What is the longest hike you can take? So in the example below, the longest hike you can take is marked in 0, starting from S. This hike contains 94 steps. The other possible hikes you can take is 90, 86, and so on up to 74. So how many steps long is the longest hike? Okay, so let's grab this input and chuck it into here. So we'll start off... Okay, we've already got our grid. And we'll do start equals for cell in grid 0 if cell equals dot cell. And then we'll do this and then just grab index 0. Then we'll do the same thing end grid -1. So print, actually we need to do 0 then that, and this will be length of grid -1. That. So let's print start end. Oh, my bad. We'll do cell index cell in enumerate grid, and that'll be CI. And then we'll do same thing here again. 0, 1, then 22. Okay, so we've got that now. So something we're also definitely going to need are the directions, which I've done in most challenges right here. So we'll grab that. So we'll do call it follow map. Pass and start and end. And we'll have a max steps, return max steps, and this will be return follow map start end. And we'll have a queue. And what will this contain? This will contain current location, previous locations, and then steps for 0. Or does this count? Does this count as a step? No, I guess we'll find out when we actually try running this, if we need to start at 1 or 0. So I may as well just grab some of the code for how this is done with the queue. If I can find the challenge which has that. Okay, so now we do while queue. We'll do for direction in... I forgot to create directions, which will equal up, down, left, right. Now for the in directions, and for the sake of not having to constantly write it out like I have before, do def combine coords. And we'll just do coord 1 and coord 2. This will return coord 1, 0 plus coord 2, 0, then coord 1, 1 plus coord 2, 1. So we'll do new coord equals combine coords. This will be... Oh yeah, I forgot to do... We'll do location, previous... Actually we'll do current location, previous locations, and current steps equals q.pop. So we'll do current location and then we do if new coord in previous locations, or new coord 0 less than 0, or basically just a bunch of this a few times, greater than... Actually, is this greater than length of grid, or greater than or equal to? And same thing here. Now for 1, then this should continue. Okay, so now that we've got that, we've got the actual coordinate. We now need to see... What do we need to see? Actually, something that we should keep record in here as well is the direction that we need to be going. So if the direction is one of the arrows, we skip this, or we keep going in that direction until we reach the end, and then we can do this as normal. So I'm just going to create a dictionary, arrows, so if it's caret, it is up. If it's greater than, it is right. If it's v, it is down. And then if it is less than, it is left. So just to make sure, yep, lowercase v. Also, because I don't think this example has all the arrows, so let's just double check in the actual input what if it has all of them. So v has v. There's no caret apparently. Interesting. It did say. Okay. So no caret. There is greater than. There's no less than. Okay. But we'll keep like that anyway. And we'll also add, I guess, none, or something. So we can do. No, that should be here. Direction. I guess we'll do, I don't know, something like. Actually, this will be slope. And then we'll do direction equals arrows slope. Then we'll do if direction. Then we will do basically this again, but instead of current direction, it'll be direction. And if new coord, can't be bothered rewriting this, we'll just do pass. And then actually something that I should also add to this check for both of them, or grid 0 1 equals hash. Actually, let's just clean this up a little bit. So if it equals hash, no, it shouldn't be inside, it should be there. Also add that to here. So I can't be bothered rewriting this one, so it's the one we want, so we're just going to do pass else. Then there'll be a continue in here. I guess this would be q.append new coord. Okay, for this I need to do previous locations dot add current location. Do that. New coord, current location, current steps plus equals 1, and slope stays as it is. Then we continue, so we'll go into here again, and I guess it would stay the same like this. Actually, new step should be a list, and we will do new coord. If new coord equals end, max steps dot append current steps. Well, this should be up here. No, current location equals end current steps. Then continue, and this one needs to return max steps. So let's see. Okay, dict object has no attributes add. This should be a set, so I need a set. Int object is not subscribe. Okay, so what line is that? 56. Oh, this would be for both of them. Until it be like this. Now I'll rerun that. Tuple object has no attributes add, but I made it a set. I'm not sure why that would happen. Print previous location. Oh, I just realized I didn't do the arrows on this part, so I need to go back and do that. How did it turn to? Oh, okay, I did current location there. Ew, there we go. Okay, so that's now running, but I forgot to do this. If cell equals grid, actually we can do that here, and I would have to actually do that here as well. So if cell in, if it's in this, then slope equals cell, else slope equals none, and do the same thing up here. And this also needs to be, wait, okay, so this, then cell equals this. There we go. Okay, let's, nope, that's not line 60. Oh, okay, so that does have to be, okay, that'll be in here, and we're just going to do this as a separate if statement. Wait, all the stuff here, this should just be continue. Okay, let's run that. Max arg is, okay, so apparently never reaches this. So let's print current location end current equals end. Okay, that didn't look, okay, that makes sense why it's not running that. Okay, I need to make end a tuple. I don't need to do all that, I can just do this. 158, that is not right. Maximum is 94. Okay, I might need to check previous locations or something. I might actually need to copy this. So what we'll do is new locations equals previous locations dot copy, and then we use previous locations. Okay, so now let's run that. 158 still. Okay, I guess something we should go through is looking at what we're actually passing in. So print here, and we'll do slope just so we can differentiate it, and we will do normal. So let's take a look at that. Okay, maybe we'll get rid of the new locations because that's taking up too much space.
So redo that. It's hard to tell what's going on really. Okay, maybe there's something in this where we've gone wrong. So less than 0, greater than length of grid, less than 0, greater than length of grid. I guess for safety we can do an actual row instead of just the whole thing. So I've got cell here, cell equals this, then continue, which is fine. It's hard to see. Okay, maybe we remove these prints, but instead we will print in here. Instead of using a set, maybe I should just use a list, and then we'll append to it. So now we can actually see the path that it took. Okay, let's see, 0, 1, 1, 1 goes up to 1, 7, 2, 7, 3, 7, 3, 3, 4, 3, 5, 3, and then continued, so that worked, the arrows work, 6, 3, 7, 3, 7, 5, 8, goes down to here, goes to here, then goes down to here. Actually, it's hard to kind of follow. Let's copy all of this. Let's just paste it here. So we've done 0, 1 to here. We've gone to here. And now we've gone down 1, 2, 3. Actually, wait, let's take a look at that again. Do I have the directions wrong? No, that looks right. Okay, no, that is correct. So then we go across to here. We go down 2. We then go to the left. We're now going down 2. Actually, no, we keep going down to there. Now going 7, 4, 5. We're going down 2, going to the left. We're going down to here, going to the right 2, going up 2, going to the right 2, going down 2, and good, it continues down. Now we're going all the way to the left, go down 2, right 2, down 2, left 2, down 2, going right all the way to here. We go up 2, right 2, up 2, right 2, then it's down to here, so that's this, then right 2, up 2, then it's right. Okay, it looks like this one failed the V. Okay, so my check, one of these checks, this isn't working. Wait, is that right? Okay, yep, this needs to go. This part needs to go. It should stay the exact same as that. Okay, now I'll remove that. Now let's try run it again. 91, that might, okay, good night. Should have been 94. And apparently only one of them worked. So is 21, 22 correct? Just so we can see, let's print start and end. Oh, that needs, okay, we'll do that here. Actually, no, we'll put that here. 22, 21. No, that's not right. Should be 22, 22. Huh. Print grid -1. Okay, so it is that. And let's try print end 0. Print end 22, 21. Let's print the length of this 23. Let's print the length of the grid in total. So it's 23 by 23. So no. Okay, yep, 21 is correct. We're in the last row, but it's the second last column. Okay, so we do have that correct. But the fact that we're only getting one time where it's at the end. Well, let's print max steps. Oh. Yeah, there's only one time where it reaches the end, apparently. So let's get rid of that print. But then let's print Q. So there's this one, which is at 1819. 1819, that's this. Or this. Okay, that's here. That doesn't look right. How? 1819, but... Oh, so for this part, I need to also do a copy. And here. I think that's probably the issue. Okay, let's rerun that. Ugh, 91 still. Well, like, how... It's got previous ones in there. Not just to be extra safe. Inside here, we're going to copy. Then inside for loop, we're going to copy. Still 91. I don't know if this is going to change anything, but I mean... I just want to make sure there's absolutely no reference between them. Nope, still like that. Okay, well I guess maybe we should do the same thing and copy this. So down 2, right to the end, down 2, left to the end, down 3, right to the end, wait, right 3, then down, so 9 across. Actually, let's ignore that. Let's take a close look at what this does. Oh, actually, so does this mean it's just the... It might be that if you're on this tile, then you can already go down. Okay, I think I've done that part wrong. Yep, so I don't need to record slope. Don't need this. Yeah, I don't need any of this. Okay, how do we want to do this? So current cell equals this, and it'll be current location, and where have we put arrows? So direction arrows, so we'll bring that to here, current direction, current cell is this, and then if direction, so I'm assuming a direction, it will always point in a way where there's a dot next to it, so let's assume that. So we will just do direction, new chords this, q append, new chord like this. So if direction continue, otherwise it will do this. And we don't need slope anymore, so do that. Also need current steps plus equals 1, which I think I forgot before. Okay, let's run it and see what that does. Arrows. Okay, so we'll change, instead of a none, will be a dot. 104. So I'm on the right track, but I did miss something here. Okay, let's find the 104 one. Then we're going to do the same thing. Let's just copy all of this. Then we'll chuck it into here. Find 104. What? There's no 104 in here? Okay. If current steps equals 104, print q. If current steps equals 104, print q, and it's giving us 97. And, well, I guess while we're at it, I may as well make this a set, and then add. Oh, I did q instead of previous locations. Okay, there we go. Okay, so we've got this, now let's go through it. So from the top, 2 down, go across to the right, 2 down, go all the way to the left, we go down 2, and then we go all the way to the right, 7, then we go all the way down, so now we should be here. 1, 2, 3, 4, 5, 6, 7, 8. Yep. Then we go 2 across. Then we go all the way up. Then we go right 2, and then we go down. So now we're here. Then we go all the way right. So is this? Assume that's 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Alright, it would be 18, and then minus 1. So then we go down 1, 2. Then go to the left, like so. Then we go down 2, so we're now here. Then we go right 2, we go down 1, then down 2. Okay, so we messed up this check. Okay, so we forgot to add that check there. So if current location, here. So if direction, okay, need to add this back in. Should be if record not in new location, then we do this. Okay. Hopefully I can just run it without saving again. Nope. Wait, it's still getting 104. Okay, I'm going to delete this. We're on 1313. Still giving 104. Okay, let's do if new chord equals 1313. Print new locations. I guess we can just do... Wait, we haven't made new chord yet. If current location... Now somehow I've got 158. What? Okay, we need to swap this around. How is that changing it? What? So if direction, new chord, doing the direction, if new chord not in location. That makes no sense that it would jump that high. Let's try if current location equals 1313. Print, we'll just print test. Okay, it's not on that one where that happens, it's down here. So test. Let's print this. Okay, so the 2 times where it comes back as true. Let's print it below there. 1 time, and it says false. Actually, maybe we can change this. If direction and direction does not equal continue. What if we did that? 98. Okay, so we're going to change this to 98. And let's copy all this and take a look at it. So down 2, go to the right. Down 2, go all the way to the left. We go down 2, go to the right 5, all the way down to here, right 2, go all the way back up. So now here, we go all the way to the right. Oh no, we go, where do we go? So we're here. Okay, we go to the right 2, then we go down, then we go to the right to here, then we go down 2, go all the way to the right here, down 2, right 2. Okay, now we're making better progress. So it goes down 2, I think to here, right? So 13, 13, 13. They're going 13, 14, 13, 15. We go down to here. Then we go right 2. We then go up to here 12. Oh, it's 11. Then we go 1, 2, 3. So 1. Okay, this is 18, 19, 20, 21. Then we go down 4. So 1, 2, 3, 4. 1, 2, 3 to the left. Oh, this is left 2. Then it's 1, 2, 3, 4, 5, 6. And it's 1, 2. Well, I don't see anything wrong with that. Isn't that like basically the same as this? Like we made that. No, we did a different path. I don't know, maybe instead of recording steps, we just length of previous locations. That's just what we do. Or new locations. Maybe that changes something. Oh, maybe that was the issue right here. 95. That might be the right one. 94. What are the chances that... Actually, how does it compare to 94? Okay, we've got different numbers. So 94, 95. Okay, yeah, it's all just... Okay, cool. It's a one got +1 at the moment, so we do -1 here. Hopefully that is the solution. So let's clear all this stuff out, and let's get the actual input. So if we put that into here, hopefully we've now got part 1 done. Where did false come from? Oh, that was this. That is taking a long time. Oh, okay, so that's done. I was worried that was a bit too brute force of an attempt, but apparently not. So we've now got that, and that is part 1 done. So on to part 2 now. As you reach the trailhead, you realise that the ground isn't as slippery as you expected. You'll have no problem climbing up the steep slopes. Now treat all slopes as if they were normal paths. You still want to make sure you have the most scenic hike possible, so continue to ensure that you never step onto the same tile twice. What is the longest hike you can take? Okay, cool. Basically the exact same thing as before. Okay, I'm going to do part 1 folly map, and then we're just going to copy all this and do part 2. And basically, just remove the directions part. So we'll comment out part 1 just so it doesn't take forever to run, and let part 2 run. Okay, that returned none. Oh, would help if I actually put this in. So part 2, now folly map, and we will let it run. Okay, so this is taking too long, which means we need to make it run more efficiently. So obviously, like now that we've removed the arrows, there'll be points. It was removing a bunch of possible options, like let's say this section right here. If we go down, we could no longer go this way, or if we're here and we go right, we can't go this way. So it's really increasing the amount of possible ways that we could go. So we want to kind of just reduce the amount of calculating that has to do. So first thing we're going to do, we're going to iteratively go through the map and just create kind of like a dictionary where you put in a coordinate and it'll give you the coordinates that it can move towards. So we'll do that at the very top here, and we will do, what we want to do, connecting cells maybe, just dictionary. Then and then we are going to, for RI row in enumerate grid, then CI cell in enumerate row. Oh, forgot to put the 4. We will do if cell in dot then these symbols. We'll then do for the in directions. We will do new coord equals combine, and this will be RICI the. And let's just grab this code that's down here. If new coord like that, continue. Otherwise, if grid new coord 0, then new coord 1 in this, we will do connecting cells. New coord. No, that not coord. New coord. This one equals connecting calls dot get this or set or new set dot add new coord, and then we need to do the same thing again. So new coord can go in this direction, so that reduces the number down. Let's see if that's enough to improve it. So then here we can do new coord in connecting cells. Don't need this, don't need this, also don't need this. Wait, we don't need any of this now. In connecting, okay, let me just, current location, connecting set location. I think that's all that needs to be done now. Okay, let's run that and see if that does anything. Okay, none type. Okay, so that was this. did I need to do this? What do you mean none type as attribute add? I'm doing a get and it's doing this. Okay, we'll do new set equals this. Print new set. Then we'll do new set dot add new coord. Okay, maybe, okay, better idea. New set, instead of doing like that, just do this and then this. Okay, surely that works now. Okay, it seems to work, so I guess now it's time to just wait and see if it actually fixes anything. Okay, so it's still running even though I've had a shower and all that sort of stuff, so let's cancel that. So I was thinking about how we could improve this. So let's say we've got this row right here. So in each of these dots, like there's only one way that it can go. Like this one can only go here, here, then that one can only go here, here, and so on. So what if we shorten the gap by going, okay, if you're on this dot, you can either go to here or here. So that will reduce the amount of iterations we have to do for it. So that is what we will change. So we'll need to change connecting cells. What we add that, so that's a set. We will do a set and then the distance to it, so 1. And then same thing here, so inside the set we have the set for the coordinates and then 1. So let's find connecting cells down here. For coord, we'll do next in that, then next, then new coord distance in next. Oh, actually we'll do equals, that's how it's done. So we're going to be changing it, so instead of using, where is it? Connecting cells, max steps, where are we doing this? So instead of using the length for this, we are going to be having a distance back, and we will be passing distance into it. So this will be distance, and it will instead, actually we'll change distance, new distance, then new distance plus equals distance will be this. So we've got that now, but now we need to change it so the connecting ones, actually it doesn't need to be straight lines. Oh, I've got an even better idea. Let's say we start on number 1 here. This goes all the way. Oh, you can just follow it until you get to like a crossroad area. It's only when you have 3 or more. Oh, okay, that is really good. So I guess using the initial one as a guide. So this one will follow all the way through until here. So you go from here straight to here and you've got the distance. Okay, that is even better. So we will start. Okay, how do we actually do this though? So we'll do for cell values in connecting cells dot items, and if length of values equals 2, then we'll do, what do we do? New cell distance equals, how do we want to do this? So if it equals 2, we get the surrounding ones and kind of join those two together. So we've got, let's do cell 1, cell 2 equals values. And then it would be, I think it would be connecting cells, cell 1, 0, dot remove cell. Then same thing here, so now it's for cell 2. Actually, let's take a look at what this is doing. So print cell values, cell 1, cell 2. Print cell values. Okay, that doesn't seem to be working. Okay, so why wouldn't that work? Print connecting cells. Okay, that's not what we want to do. That's way too much. Print. Wait a minute. Okay, this is wrong. Actually, no. Maybe we should keep the dot add and this in there because it's a set, so it's just going to. Yeah. Okay, so let's keep like that and then rerun that. Oh, why is it saying none type? How is that returning none? And we're literally setting it up. Okay, maybe do this. So it worked there, but then it didn't work for this one. What? Okay, we're just going to change this, so we're doing if this not in cells this equals this, else this dot add this. So I got not, like, it shouldn't be messing up like that. Now we're doing the same for new record, and then we've got this, so that's going to work, right? Line 89? What? Why wouldn't that work? Okay, well, it's print cell values then. Wait, what happened here? Okay, print connecting cells. Okay, this is looking better. Okay, let's go back to this. So it's messing up here. Line 88. So key error 11. Why isn't 11 in it? Print connecting cells 11. I mean, we literally got it right there. Or maybe it's this one where it's not going correctly. Okay, we need to change this to be... Okay, it's going to be a dictionary, not a set. Add, and it'll be new coord distance. Invalid syntax, which one? Should be like this. And then this. Line 77. Okay, so it's not add, it's this. Equals 1. And then same thing here. Wait, no, that's meant to be that one. So we do this, and this equals this, right? Okay, we've got that. Let's print connecting cells. So 140, 139 has that. 139, 136 has 139, 135, 139. Okay, that is looking correct now. Okay, so now let's go to here, line 87. This is meant to be del this, and then del this. Okay, still not working. Print this. Oh, actually, because it's now a dictionary, this might have changed. Print values. Okay, it's now a dictionary. Values.keys. Print cell 1, cell 2. If we remove the keys part, okay, no, that worked before, but we'll do it as keys just so it's specific. Okay, let's print connecting cells 1 like that. Alright, we don't need to do this anymore, because I've actually just got the key straight up. Okay, so that now seems to be working. So we'll do print and cell, and then do this. Alright, square brackets. Okay, so that is working. Oh, actually, that's not even changing. We should be doing this, and then this. Okay, so I need to actually change this. We'll do... So we've got cell 1, cell 2. We'll do distance 1 equals this cell 1, and then distance 2 cell 2. Print cell 1 distance 1 cell 2 distance 2. Okay, that seems to be working. So we're removing this one, but then we are then doing cell 1 cell 2 equals distance 1 plus distance 2, and swap these around. So let's print both of those now. Cell 1, now cell 2. Okay, well 198 is definitely not correct. Or maybe it is. You know, let's let that run, and let's print connecting cells 1, 1. Hide these prints. Now let's run that. Okay, well that only goes to... So that's not working, or is it? And let's just try, see what... No, don't need to do anything like that. Let's just do 2, 1. What does 2, 1 have? Okay, so it worked, kind of. That goes to 3, 1, which should have carried on. So why didn't it go all the way to 3, 1? And 3, 1 only has distance of 2 to there, which it should have been 3. Okay, we're going to do one iteration of this and see what is happening. I'm not sure what happened there. Let's go on a cell. Then we'll print connecting items cell. So we're on 1, 1. Okay, 1, 1 has these two. Oh, okay. That makes more sense. So really we should be printing it like this. Okay, so we're on 1, 1. 0, 1. What? So 1, 1 has 1 to 0, 1, 1 to 2, 1. And 0, 1 has 1 to 1, 1. 2, 1 has 1 to 1, 1. Then 1 to 1, 3, 1. Okay, there we go. Let's do count equals 5. Or count equals 0. Count plus equals 1. If count equals 5. Exit. So we can get more. So this one worked. It then went on to 2, 1. And 2, 1 has these. I don't know, that does seem to be working. Wait, what did I do before? What was I printing when I tried to check? I did print 1, 1. Which, actually, even then, we need to be removing... Once this is done, we then need to delete the original one. So, del connecting cells, cell, like that. Okay, so it's going to throw that error. Okay, what should we do then? Because it's going to fail on this, and we need to keep running. Okay, I got an idea. While true, we are going to run this. When we get to here, we're going to break out of this for loop, and we're going to put an else here. So when the for loop has finished completely, else break. So we'll get out of the for loop. But if we break here, it's going to go below that and continue running. Okay, now let's run it. Key error 19. Line 114. Wait, 19. Current location. Wait, what? Okay, I'm messing something up with this. Okay, what is next? Okay, yep, so next coord. Distance in dot items. Wait, what do we have before? Alright, so new distance like this. Let's run it. Okay, that looks like it's going in circles. Because I somehow removed the check if it was connecting cells. When I need to look at part 1. If new chord and new locations, do I still have new locations? Okay, I still have it. If new chord in new locations, continue. Okay, still doing that. Wait, why am I adding distance into it? Should be current location into new locations. And then, this is part 2, right? Yeah. So is that fixed it now? Okay, seems like it hopefully has. So, I'm going to let it run and hopefully it works. Okay, it's finished running and it's given us this number. What was the previous one? Okay, so it's a bigger number than that. So hopefully it is the correct number. Yes, it is. Ah, finally. Okay, awesome. That is day 23 of Advent of Code 2023 completed. If you like this video, make sure to like and subscribe so you can watch me complete the rest of these challenges.